Good afternoon, students. So, in previous class, we are discussing about the polar curves. Okay. So, by using the polar curves, we have to find out the MSCP and MHCP values. Okay. So, from polar curves, by using the rosy diagram, you have to find out the mean spherical candle power MSCP value as discussed in previous class, as well as you are discussing the street lightning and factory lightning. Now you have to in this class you have to discussing the methods of lightning calculations. Okay, to find out the lightning. Okay, by using the calculation, here you have the three methods. Okay, those are see. There are so many methods have been employed for lightning calculation. Some of those methods are as follows. So there are so many methods are there to find out the uh, lightning. That is nothing but illumination. But here in this one, in this subject, you have follow these three methods. Those are watt per square meter method, luminar light flex method, point to point method. Okay. And so these are the three methods. Here you have to follow the find out the lightning. First one is what? Watt per square meter method. Okay, so see in watt per square meter method. So this method is very handy for rough calculations. Okay, so for doing the rough calculations on the lightning, this watt per square meter method is used. It consists in making an allowance of watt per square meter or of the area to be illuminated according to the illumination desired on the assumption of an average figure. Okay, see, whenever you have been taking a one surface, an average, so at that time, watt per square meter method, the name itself indicates, it measures the watts only per square meter. Okay, so of overall efficiency of the system, whenever you have to considering the lightning and the overall surface, at that time, the watts per square meter method only allows the per square meter only. Okay, that's why its name is called as watt per square meter method. See, luminar light flex method. Okay, this method is applicable to those cases where the sources of light are such as to produce an approximate uniform illumination. Okay, so over the working plane. So whenever you have to produce not purely uniform illumination, some cases you have to appreciate illumination at that places on the working plane. At that places, we are using the luminar light flex method. So in this, you have to find out the lightning. That means in this method, you have to find out total lumens required is equal to number of lamps into wattage of each lamp. Okay, so number of lamps means total. Okay, total in the, if suppose if you are considering one room, so in one room you have to take in total how many lamps. Okay, so as well as wattage. Okay, that means power of each lamp and efficiency of each lamps. So efficiency you can take in terms of lumen per watt. So and coefficient of utilization as well as maintenance factor. We have to consider all these parameters. So at that time you have to find out the lightning value. By using this formula, you have to find out the lightning in the luminar light flex method. Next one is point to point method. Okay, so this point to point method, this method is applicable where the illumination at a point due to one or more sources of light is required. So whenever you have to find out at a one particular point, you have to find out the lightning, that is illumination value. So at that time you have to, so by using the one or more sources of light, okay, source is more, okay, but you have to find out at one point. Okay, so at that time the candle power of the sources in the particular direction. So at the time you have taken the particular direction. This method is not much used because it has the complicated applications. Okay, so it is employed in some special problems such as flood lightning, add lightning, etc. Flood lightning is nothing but that lightning, okay, which is used in the stadiums and auditoriums. Okay, so that lightning is called as flood lightning. Ad lightning means some large space. If suppose you have to take market yard like this, so in some ad you have used lightning, that lightning is called ad lightning. Okay, in these places you have to find out the lightning or illumination. At that time you are go for the point to point method. See, in this, in point to point method, you have to find out, so how many number of lamps will be used. So here you have to formula n equal to E into, so this that indicates multiplication. E into A divided by O into UF into MF. So N is nothing but number of lamps required. Okay. E equal to illumination. A means working area. O means luminous flux produced per lamp. UF is nothing but utilization factor or coefficient of utilization. MF is nothing but maintenance factor. Okay. So in point to point method to find out the number of lamps, how many lamps. So by using this formula, you have to know illumination. If suppose you have to know number of lamps, so from this you have to find out E equal to N. So at the time you have to total write these terms in this side. N into O into UF into MF divided by A. So at the time you have to find out the illumination value. Okay, by using this formula, okay, by using this formula you have to find out the illumination in the point to point method. Okay, so these are the three methods are used to find out the lightning calculation. Those are watt per square meter method, luminar light flux method, point to point method. Okay, so next one is problem. Okay, so in problem here you see, you have to note the problem in notebook. Okay, see, a room a room having dimensions 20 length 10 meters breadth is illuminated by 60 watts incandescent lamps of lumen output of 1600 lumens. Okay, so if you take a, all of you please note the problem. So if you take a one room, okay, so whenever if you take one room having the dimension is 20 into 10 meters is illuminated by 60 watts incandescent lamps. Okay, by using the 60 watts in output of 1600 lumens. So it will give the output of 1600 lumens. The average illumination required at the workplace is 300 lux. Okay, E value will be 300 lux. Calculate the number of lamps required to be fitted in the room. Okay, so now you have to find out the number of lamps. Okay, so to in the room you have you want 300 illumination, 300 lux illumination. At that time you have to know, you have to use how many lamps in that room. Here you can assume utilization and depreciation factors are 0.5 and 1 respectively. This is the problem. Okay, so from this, first, the area given data. The area of the room is A equal to 20 into 10 meters. That is, so note down all of you first problem. I will wait 1 minute. All of you note down the problem in the notebook. So now given data, the area of the room A equal to 20 into 10. So that means 20 meters into 10 meters. So at that time we have to write 200 meters square. This is the area. Total illumination required E equal to 300 lux. Okay, that is illumination have denoted with E. Okay, so at that time here you can write E equal to 300 lux. The wattage, okay, the power of each lamp will be given as 60 watts. Okay, so the luminance output is 1600 lumens. Okay, UF utilization factor equal to 0.5 and depreciation factor equal to 1. Okay, so all of you note this given data also. So next one is, see, maintenance factor is nothing but 1 by depreciation factor. So you have to formula is number of lamps required n equal to E into A divided by phi into UF into MF. O or phi. So in previously you have to write O, that is nothing but phi. Okay. So but here in this total data you have no E value problem will be given, A value will be given, phi value, flex, total flex output, phi value will be given, utilization factor will be given, but maintenance factor will be not given. So maintenance factor is nothing but 1 by depreciation factor. Okay, so the ratio, so the inverse of the depreciation factor is nothing but maintenance factor. At that time you can write 1 by df. So at that time 1 by, so the depreciation factor in the problem is given as 1. So at that time here you can write 1 by 1 is equal to, at that time you can get 1. So at that time so the total lamps required. So the formula, so in previous you can discuss it in point to point method, n equal to E into A divided by phi into UF into MF. Illumination, area, total flex output, utilization factor, maintenance factor. Okay. So now write E value will be 300, A value will be 200, phi value will be 1600, UF value will be 0.5, MF value will be 1. So total you have to write down. At that time total you can calculate, you can get 77.5 lakhs. That means approximately the number of lamps required for the room will be how many lamps? How many lamps? 7.5 lamps is nothing but approximately you can use 8 lamps. Okay, so this is the one of the simple problems asking for 5 marks or 2 marks. Okay, all of you note down this one also. So again I will go back to back slide. So all of you note down given data first of all.
ప్రియా నీ ఆడియో మ్యూట్ చేయమ్మా ప్లీజ్ మ్యూట్ యువర్ ఆడియో
So let's note down prompt. Okay. So now do next problem. See, first listen the problem. Read the problem. A drawing room with an area of 18 into 12 meters. That means 18 meters length, 12 meters breadth is to be illuminated with an average illumination of about 150 lamps. Okay, so the room is illuminated with the average illumination of 150 lamps. Okay, so that means E will be 150, area will be 18 into 12, that means 216 meters square. The lamps are to be fitted at 16 meters height. Okay, so the height will be 16 meters. Find out the number and size of incandescent lamps required for an efficiency of 20 lumens per watt. Okay, so utilization factor is 0.6, maintenance factor is 0.5. So here you have to find out the number of and size of the incandescent lamp. So first you have to write down this problem, all of you. Okay, so given data is efficiency is 120 lumens per watt, illumination E equal to 150 lux, area A equal to 18 into 12 equal to 216 meters square, utilization factor equal to 0.6 and maintenance factor is 0.75. So total lumens required. So in the problem we will not phi value. Okay, to find out the phi value we have to problem formula is E into A by UF into MS. Okay, so at that time here E in illumination is 150, area will be 260, utilization factor in the problem you have to given 0.6. Okay, so and maintenance factor is 0.7. So at that time you can get 72,000 lumens. The total wattage required. So in the problem also only efficiency will be given. So there will be not given the total wattage required. Okay, so the total wattage required is 72,000 by eta. Okay, that means here you can have total gross lumens by efficiency. So at that time here you can get the total wattage required. 3 days. So in the problem you have to given efficiency will be 20, na? 20 lumens per watt. So at that time here you can write 72,000 by 20. At that time here you can get 36, so that 3,600 watts. Okay, so that is the total wattage required. Note down this one. So if suppose here you can assume, if suppose 24 lamps are arranged to illuminate the desired area. If suppose for our given area you have to assume 24 lamps will be arranged. So for space to height ratio is unity, that is 6 lamps are taken along the length with a space of 18 by 6. See, you have to given the length will be length 18 meters, breadth 12 meters. So at the time 6 lamps are taken along the length with the space of 8. So at the time it requires 3 meters and 4 lamps are along with giving a space of 3 meters. See, at that time here you can, this is only assumption. Okay, at that time total wattage of each lamp. So here you can assume 24 lamps. 3600 by 20 means the wattage of each lamp will be 150. Why? Because the total wattage of all lamps is 3600. Whenever you have to take the wattage of each lamp, you want the wattage of each lamp, at that time you can take 3600 by 24. At that time you can get 150 watts. See, at that time this is the arrangement of the 24 lamps, okay, in a 18 into 20 meters, 12 meters room. So 18 meters length, okay, 12 meters breadth. So at that time here you can arrange these 24 lamps like this. Here you have to take 1.5 meters, this 1.5 meters, this is height is 3 meters. See, here you can get height is 3 meters in according to breadth. Okay, so so that is only, that is our assumption. Okay, so write down this one. So next, note down continuation. Okay, so up to now you have completed the first unit. Okay, so in first unit we have to discussing. So first of all, what is light? Okay, so what is the nature of light? Okay, so and next one is and definitions. So many definitions related to the light. Okay, so and for lightning calculations we are using the polar curves, Rosy diagram, and you have to see the artificial sources of lamp. Okay, so all of you know natural source of light is sun. So artificially you have to produce the light. You have to follow the three ways. Those are by producing a arc between two electrodes. So next one is what? By passing the electrical current through a filament. And next one is by discharging the gases through a lamps. Okay, so these three are the artificial sources of light. So in this one, in um, by producing a arc between two electrodes, those are nothing but the arc lamps. So in arc lamps we are discussing about the carbon arc lamps. Okay, similarly, by passing a current through a filament or wire, okay, is nothing but the tungsten filament lamps. In filament lamps we have discussing the tungsten filament lamp. Similarly, in discharge lamps you have discharge a vapors of gases. So in discharge lamps you have to discussing the so many lamps: sodium vapor lamp, okay, a neon lamp, halogen lamp like the CFC, chlorofluorescent lamps, okay, the compact fluorescent lamps, so CFL lamps. Okay, so like this. So next you have discussing about what is street lighting and what is factory lighting. So next you have discussing the types of lightning schemes. Okay, how to arrange the lightning schemes. Okay, this is very, there are 5 types of lightning schemes. What are those? Direct lighting, indirect lighting, semi-direct lighting, semi-indirect lighting, general lighting or diffuse lighting. You have to see the lightning, different types of lightning, and you have to see the design of lightning schemes. Okay, so what are the factors to consider the design the lightning schemes? So next you have to see the street lighting, factory lighting, and you have to see the lighting calculation method, and you have to see some 2 problems like this. So this is up to total now first unit. Okay, so today in this class we are completed the first unit. In next class I will start the second unit.